Hey guys, and welcome back to this video provided by Turtferg Incorporated for all your physics needs. All right, so we've been talking about constant acceleration. We've done one example, so here's a second example. And here's one about a super deluxe sports car accelerating from rest to 87 miles per hour in, oh my goodness, it's been snipped off a little, in 8 seconds. So I almost lost it on my screen. Sorry if my writing on this one is a little bit small, so I'll try and blow that up real quick. Maybe I'll keep it on the screen. All right, so here's what we've got. I'm going to go back and I'm going to grab our basic equations that I told you we can solve every single one of these 1D motions using this information. So let's paste this in here and see where we can go from here. So we've got this velocity initial, velocity final. So let's go back and read this problem and actually see exactly what it tells us. So it claims that super deluxe sports car will accelerate from rest. So that tells me that my initial velocity is 0 meters per second, just like our last example. And it says we'll accelerate to a speed of 87 miles per hour. Now that's something that we will obviously have to deal with. And it says that it does it in 8 seconds. So there's my last bit. And so generally the rule of thumb on working these problems is we need to have 3 pieces of information. Well, if you can tell, we've got 3, which means I should be able to find, and I haven't even read what A, B, and C are, but we should obviously be able to find the acceleration of this car, and we should be able to find the displacement of the car. Well, before we go any further with this one, let's contend with this 87 miles per hour. So I know that if it's 87 miles, hopefully you know how to do this, and if you can, just fast forward for a second. And I hope by doing this, you don't mean hit Google. You need to be able to actually solve this out. Change miles to meters and hours to seconds. So notice how I put the miles on 87 miles on top of the engineering bar and hours below. And I'm going to go ahead and fix the hours first because a very quick, I know there's 60 minutes in an hour, 60 seconds in a minute, so that's 60 times 60. I know there's 3,600 seconds in an hour, and that kind of resolves the problem with the hours. And you're probably going, my teacher always makes me mark the hours out. Well, they're a good teacher. Just in case I mess up, I usually don't do that. So now for the miles, I know there's 5,280 feet in a mile. And so just like I was teaching it, if miles is on top here, miles has to be on bottom of this next engineering bar. So I know there's 5,280 feet per 1 mile. And somebody out there goes, I know exactly how many meters are in the mile. Well, didn't use it. I don't. I know there's 1,760 yards in a mile, but that doesn't help me now. So now feet to meters. I know there's 3.281 feet in a meter. And now if you wanted to, I could actually go through and start canceling things out and see if it makes sense. I've got hour cancels hour, mile cancels mile, feet cancels feet. So we end up with exactly what we're after. Speaking of which, what we're after is, let's see if we can get this. So what would we have here on the, on the top, we would have what? 87 times 5,280 divided by 3,600 times 3.281. And using my Casio, it makes that very handy. So it's 38.9 meters per second. And of course, this is actually a conversion that happens a lot, miles per hour to meters per second. So it would be worth your time. I don't remember it off the top of my head. I almost feel like 0.452. If I got that right, that's like me complete up straight balling right now. So 87 times 0.452. Let's see if I got that right. 39.3. Oh, I got close. I knew it was around that number though. So there, you can go through and figure out a little quicker way of doing miles per hour to meters per second because you do it so often. So, all right, we've got this work. So now, well, maybe we should read the problem. And it says, find the acceleration of the car. So the first thing it wants me to do is find the acceleration. So I start going through my list of equations, and the first one doesn't have acceleration, but let's look at the second equation. And that's basically nothing but our average acceleration equation. I've just got it solved for v, and that would definitely be the easiest way. Now, your teacher may want you to solve this equation for a before you solve it, and that's good. And if you were in like a 10th grade class or something, I would make you, but let's just get an answer is what I'm after. So I'm going to go ahead and do this. I've got the equation. There's only one unknown. I know that 38.9 is equal to 0 plus a times 8 seconds. And again, somebody would complain because I always leave these units out, but it really, when we get to working harder problems, it really makes a mess of things. So essentially what we've got here is what 38.9 equals a times 8 seconds. And so all we'd have to do is, as soon as I find it, 38.9 divided by 8, and that's equal to 4.86. So our acceleration is 4.86 meters per second square. And you could look at this and be like, are you sure? Well, yeah, we can go back and look at our units. Let's see, 38.9 was a velocity, so that was meters per second. And we took meters per second and divided by a time, 8 seconds, so we divided by seconds. So meters per second divided by a second, well, that's essentially multiplying by the reciprocal, which is a meter per second square. So obviously we've done that one correctly. So now we've got A, and we know that it's 4.86 meters per second square. So let's go ahead and find this position that will be this next thing given. And lo and behold, I've got a formula already ready for it. So you notice something, even though I've got that formula written right there, I'm still going to write it down, as I encourage you to write it down every single time as a student as well, simply from the standpoint it will help make sure you remember the equation and memorize it. So I'm going to go ahead and do something. I know that VOT is 0, so I'm going to go ahead and just save me a moment of time, and I know that's 0, so that's not even going to be there. So what would be my position or my displacement of this car? Well, it'd just be 1/2 times my acceleration, which is 4.86 meters per second square, times time, which is 8 seconds square. So let's pull up that calculator again. I'm going to go 0.5 times 4.86 times 8 squared is 64. And we've got 155.5. So it's traveled 155.5 meters from where it initially started. So, hey, that's good. So we've got our X, we've got our A. What is the speed of the car 10 seconds after it begins its motion, assuming the acceleration remains constant? So what we've really got here, I'm going to extend the page. Let's take a look at this again. Assuming everything remains constant. So here's the problem. Knowing that it started from rest, knowing that the acceleration is 4.86 meters per second square, what is the velocity of the car after 10 seconds? And hopefully all you would do is go directly towards this velocity equation. V equals v sub 0 plus at. V sub 0 is actually 0. And so all we would do is 4.86. I'll even write my units down this time. Meter per second square times 10 seconds. If you look, meters per second square times a second, the square gets canceled by that second. We're left with a meter per second, so it's 48.6 meters per second. And that's kind of a good basic run on how to get started working some of these problems. And I'll keep going through, so it depends on how much help you need. I'll do about 4 examples. I'm also going to do a couple of those chase problems. Anyway, we'll see you in other videos.